We're going to talk about solving quadratic equations some more. This time we're going to talk about solving them using square roots. Using square roots is good in very specific cases with very specific quadratic equations, but it's a very simple way to solve a quadratic equation. So we're going to do some examples. Solving quadratic equations using square roots is perfect when you have a quadratic equation that has no b term. So a quadratic equation that looks like this. It just has an x squared and then a number, or a 4x squared and then a number. If that's all that it has, then solving using square roots is the best method to solve. Now, if you remember yesterday, I told you that when you find the square root of something, like, for example, the square root of 49, it has two answers. One of the answers is 7 because 7 times 7 gives you 49, but the other answer is -7 because -7 times -7 also equals 49. So it does have two answers. That's going to come into play today when you're writing your solutions. So this first example, x squared equals 225. Well, if I want to know what x equals, that's my only goal, is to find out what x equals. I can make this equal 0 and factor, but there's no reason to do that. My only goal is to find out what x equals, solving an equation. And so if I want to find out what x equals, if I want to undo x squared, if I want to undo squaring something, I just have to take the square root. So I'm going to take the square root of both sides of this equation. Well, the square root of x squared is just x, because x times x gives me x squared. And the square root of 225 is going to be 15, but I'm not just going to write 15 because it could be 15 or it could be -15. So my answer is going to be plus or minus 15 because it can be either one of those. This is how I get my two solutions. My two answers to this problem, if I'm going to write them as ordered pairs on the graph, are going to be 15, 0 and -15, 0. These are the two places it crosses the x-axis. But instead of writing this down twice, I can write it as one statement, plus or minus 15. It tells the person reading your paper or looking at your answer that it is both of those. So that's the square root thing. So now this next one. I have 4x squared minus 25 equals 0. Again, I could factor. This is a difference of two squares. I could pull that out and factor it and solve it, but I don't have to. Because this does not have a b term, using square roots is probably the easiest way to do this. So what we want to do is get x by itself. If I want to get x by itself, I'm going to treat this like I do any other equation I have ever solved, and I'm going to start moving stuff. So I'm going to add 25 to both sides. So you have 4x squared equals 25. X, however, is still not by itself. Okay? So I'm going to have to divide both sides by 4. I'm not actually going to divide out 25 by 4 yet because that doesn't come out to a nice pretty little number I want to work with. So what I have is x squared equals 25 over 4. Now think about the numbers 25 and 4. What makes those two numbers special? Well, what makes those two numbers special is that they are both perfect squares. So if I take the square root right now with it as is, it'll make this much simpler. So again, the square root of x squared is x. And if I take the square root of this fraction, I got to take the square root of the denominator and the square root of the numerator. I got to do them both. So the square root of 25 is 5. And the square root of 4 is 2. And so my x equals plus or minus 5 over 2. So it's both of those. It'll be positive 5 over 2 and it'll be negative 5 over 2. You could have divided this and then taken the square root and you probably would have gotten the exact same answer, but this is just easier. Both of these are a square root. Just square root it and leave it as a fraction. If you want to write plus or minus 2.5, more power to you, but that does mean the same thing. So another example. This one, x squared plus 100 equals 0. It's a lot like the one I just did. I want to get x by itself. That is my whole goal. Find x. Because the answer to your quadratic formula is going to be the x value because it's where it crosses the x-axis. So I'm going to get x by itself. So I'm going to start by subtracting 100 on both sides. So I end up with x squared equals negative, wow, with the long negative sign, negative 100. My pen is having a total spaz attack. I apologize. Let's try this again. Equals negative 100. And then, because I want to get x all by itself, I just want x and not x squared, I'm going to take the square root. And so I end up with x equals, well, the square root of a negative number, we don't know how to do. We're in Algebra 1. We haven't learned that. And if you type into your calculator the square root of negative 100, it is going to come back with an error, and it's going to say non-real answer. That's because the square root of a negative number is not a real number. And in Algebra 1, we only work with real numbers. You won't work with anything that isn't a real number till you get to Algebra 2. We cannot find the square root of negative 100. There is no number multiplied times itself that equals a negative. You just can't do it. 10 times 10 is 100. Negative 10 times negative 10 is still 100. And if I switch it and I do 10 times negative 10, those aren't the same number. So there is just not a number times itself that will give me negative 100. So this I cannot do. Okay, so I have x is equal to the square root of negative 100, which is something I had no solution. Because if I try to graph this, it will not touch the x-axis, and so there is no solution. So if you get a negative in that square root symbol, and what we call the radical, you have no answer. Now this next problem is perfect for solving using square roots because it is very difficult and a very long process involved kind of problem to solve if you want to solve it doing any other way. If you want to factor this, or you want to graph this, or you want to use the quadratic formula, this problem right here is much harder. However, if you know how to solve using square roots, this problem is very simple. We want to get x by itself. That is our entire goal. I can't at the moment though because I've got this times 4 and then it's inside parentheses and it's all squared. Well, let's get rid of the times 4 first. So we're going to start by dividing both sides by 4. So I have x plus 2, the quantity, squared. And then 324 divided by 4 is 81. And so I have this whole thing, x plus 2 is squared, and it equals 81. Well, since this entire thing is squared, if I take the square root of this entire thing, it gets rid of the squared thing. But if I do something to one side, I got to do it to the other. So this square, taking the square root of this, gets rid of the squared. So this just becomes x plus 2. And the square root of 81 is 9. Well, now if I want to get x by itself, I just have to subtract 2 from both sides because we all know how to solve an equation. So x equals, sorry, this is plus or minus 9. I had to step back. Now we have two problems. I almost messed this up. I have to subtract 2 from both sides, but I have to subtract 2 from positive 9, and I have to subtract 2 from negative 9. So we'll do the positive 9 first. 9 minus 2 is just going to be 7. But if I do the other one, negative 9 minus 2, well, negative 9 minus 2 gives me negative 11. So my two solutions are 7 and negative 11. This is why it's very important you not forget that plus or minus because it will affect your answer, especially in problems like this. But this problem, I promise you, is 10 times easier to solve if you will solve using the square root method than trying to do any of the others. And so there's your two roots. Now let's extend this to some application word problems. Oh, I take that back one more. We're going to solve another one. Okay, it says to round your answer to the nearest hundredth. That's 2 decimal places. Okay, again, we want x by itself. So step 1, we're going to subtract 80 on both sides. And so I have negative 80 equals negative 2x squared. But I still need x by itself, so I'm going to divide both sides by negative 2, which gives me 40 equals x squared. I'm still going to take the square root. I'm still going to use that method. I'm going to take the square root of both sides so that I can have just an x and not an x squared. But 40, y'all should know, is not a perfect square. That's when we take our calculator and we ask it for the square root of 40, and it says round our answer to the nearest hundredth. So it looks like on my calculator the nearest hundredth, that becomes 6.32. And since it's an approximation, we use the squiggly little equal sign and not the straight one. So x is about 6.32. It's a good estimate. It will get you to the answer that you are needing. Okay? But again, don't forget it's plus or minus. It has to include both of them because they both will multiply to equal the 40 whenever you multiply them together. Now let's apply this to some actual application problems. Scoot this down. So a zookeeper is buying a fence to enclose a pen at the zoo. You do not need to write this problem down, but it would not hurt for you to draw the picture. The pen is an isosceles right triangle. There is already a fence on the side that borders the path. The area of the pen will be 4,500 square feet. The zookeeper can buy the fencing in whole feet only. How many feet of fencing should he buy? So he needs to fence these two sides of the pen. I have to do them both. Well, if y'all remember, area of a triangle is base times height divided by 2. Well, I know right now that the area of the pen is 4,500. It tells me that in the problem. The base of my triangle is x. The height of my triangle is x. I have to divide that by 2. So let's do this. X times x is x squared. So I have x squared divided by 2. And just like the problems before, I need that x squared by itself so that I can take the square root to get x by itself. How do I get rid of something in the denominator? Clear out that fraction by multiplying both sides by 2. That makes these cancel. And that gives me 9,000 over here equals x squared. And I need to get x because I'm trying to find out how long each one of those sides are. So I'm going to take the square root and the square root and the square root of 9,000 is 94.8. Now it says that he can buy this in whole feet only. So if he buys 94 feet of fencing, this actually comes out to 94.8 about, plus or minus. But he can buy only whole feet. So if he buys only 94 feet of fencing, is that going to cover one side of his pen? No, because he's still got 8/10 of a foot. So he needs to buy 95 feet of fencing for each side of his pen. Now think about this. I have two answers. I got plus 94.8 and minus negative 94.8. The negative one does not matter here. Because of the problem situation, you are building a pen to enclose animals at the zoo. It's a real object. We cannot have negative length or negative width on something. So the negative isn't going to matter. You still need to write it so you understand that you have both of those solutions for the function. But for the situation, all I need is the positive. So x for this situation is going to be 95 feet. That still doesn't answer my question, though. I need to know how many feet of fencing he needs. Well, he's got to put 95 feet here, and he has to put 95 feet here. So I'm going to have to multiply it times 2 so that I can have my how many feet of fencing he needs. So he needs 190 feet of fencing for this pen. He'll have some left over, can use it to make a decorative little thing or whatever, but that's what's going to happen. And so there it is applied.